So good evening, ladies and gentlemen. I'll make this brief. First, a show of hands. How many of you have heard all my jokes before? 1, 2, 3. Okay. Everybody who shouts out one of the punchlines and gets it right gets a free beer. Okay. So that's what I look like these days. I'm a lot older than that first picture. First, Creative Commons attribution. Do anything you want, just give us a link back. Let's get into the real material. 7 Years' War actually lasted 9 years because, according to British historians, the first 2 years in North America don't count. It was only colonials dying. During that war, the British lost about 1,500 sailors to enemy action, and the population of a small city, almost 100,000 people, to scurvy. Hands up if you have ever seen pictures of scurvy. There's a reason I don't show it up here. Okay, your gums go black and swell up and then start to bleed and your teeth fall out. Same thing happens to your fingernails, and then the bad stuff starts. Right? It's really horrific. It looks like you're rotting alive. And the ironic thing is, none of those guys had to die. 1747, a Scottish surgeon named James Lind did what we think was the first controlled experiment in medical history. He said, look, we know how to pickle vegetables and pickle meats so that they don't go bad. Why don't we pickle the sailors so they don't rot? I mean, yeah, it's not the right cause, but at least he's thinking. We know how to stop the meat from rotting. Pack it in salt. We know how to stop the vegetables from going bad, stick them in vinegar. So, took 12 sailors, split them into 6 groups of 2. 2 of them got cider, yay. 2 of them got vitriol, which is a weak solution of sulfuric acid, sucks to be them. 2 of them got vinegar, 2 got seawater, 2 got barley water, and 2 got oranges. And they got better. Right? They actually survived the experiment, some of the others didn't. So he wrote it all up and he published it, and the Navy ignored him, because he's a Scot and a commoner. It's not until the experiment's repeated in 1794 by an Englishman with a title and a double-barreled surname that anybody cares. This is why we speak English rather than French. The British fleet could stay at sea for months and remain effective. The French didn't start giving their sailors orange juice or then later lime juice, which is why we call British sailors limeys. So the French fleet could only stay at sea for 3 or 4 weeks before half of the sailors were incapacitated. This is why the British won the Napoleonic Wars. They could keep the blockade going. Hey, gosh, look, you pay attention to evidence, good things happen. Right? Well, unless you're a doctor, it took the medical profession about, I don't know, 150 years to figure out that maybe the science stuff actually works. Right? In 1920, none of the entrants to medical school at the University of Toronto had a science degree of any kind. It was not required. Medicine was something gentlemen did, and I do mean gentlemen. They were all male at the time. By the end of the Second World War, things were changing. 1950, Hill and Dahl did the study that you've never heard of, but it has put all those warnings on the cigarette packs. You see, by the end of the Second World War, there was an epidemic of lung cancer, and nobody knew why. Today we know it's because of smoking, but at the time, is it radio waves? Because radio has become more popular over the last 30 years. Is it automobile exhaust? Car ownership was a rare thing in 1910. It was ubiquitous by 1950. There's a whole bunch of possible causes. They did the study using British doctors as their subjects that definitively showed the correlation between smoking cigarettes and lung cancer. And it turns out it was the First World War when tobacco companies started pushing cigarettes and got men to stop smoking pipes. So that instead of keeping the smoke in the mouth that's drawn down into the lungs, your body has much less protection. You die. So, that study actually ran until 2001 when the last of the doctors died. Longest running medical study in history. So what did we learn from it? Number 1, smoking causes lung cancer. Number 2, most people would rather fail than change. How many of you smoke? Please stop. I am tired of burying students. Quite seriously. You know what it's doing to you. And yet, there's a lot of hands. I know at least 3 people here who smoke who didn't raise their hands. Right? Most people would rather fail than change. A lot of us have been in that relationship. Right? The interesting thing is that in 1950, when the study was published, the president of the British Medical Association said, and I'm going to try to do the accent, what happens on average is of no help when one is faced with a specific patient. Very high on the not getting it scale. You're right, by the time somebody has lung cancer, knowing that smoking increases your chances of getting it doesn't help you. But Jesus Christ, knowing that smoking causes lung cancer tells us what we ought to be doing, right? I want to see some heads nod here, even in the back, thank you very much. If you're interested in this stuff, go and check out the Cochrane collaboration site. Every medical study they can get their hands on, along with the supporting data, the analyses, everything is publicly available and curated. It's wonderful. Why do I bring this up? Well, let's have a look at where we are in software. This is Martin Fowler. Hands up if you've heard of Martin Fowler. He invented the term refactoring. He built some of the tools you use. He's got a brain the size of Idaho. He's smart. He's a much better programmer than I will ever be. And back in 2009, he wrote a very influential article about domain-specific languages, DSLs. Doesn't matter if you know what they are. Rattle through the quote. Using this thing gives you two benefits. Improved programmer productivity, better communication with experts. Okay? Here's the treatment. Use a DSL. Here are the effects. Better productivity, better communication. So let's take a look at what happened. One of the smartest guys in our industry made two substantive claims of fact in a peer-reviewed journal. IEEE software is not a small journal. It's one of the leading journals in our field. There's not a single citation, there's not a single scrap of data cited in the papers. The editors didn't expect it, and he didn't expect it, because that's not how we do things in software. You wander around in our field, and you would think that 2 beers and an anecdote about a startup in Boston is all the proof you need that we should be using functional programming languages on GPUs in the cloud. Okay? Hands up those of you who are in marketing. Okay, keep your hand in the air if you've watched a show called Mad Men. Anybody here a Mad Men fan? Okay. A lot of people talk about its portrayal of gender roles and women slowly realizing that no, they don't have to put up with this. What I see when I look at that is how blind they were. You start an ad campaign in the 1960s, you have no way of knowing what impact it's actually having. It'll be months before you get sales data. There will be hundreds of confounding factors. You live in a completely different world. You stick the ad up today, and within hours, you're going to be able to see changes in how many sales we got. What's the demographic of this? You guys live and breathe this data. Hands up if you do that with your software engineering team. Hands up if you have that kind of data for your development team. Right. One of these things is not like the other. Okay? We're flying blind. And it's needless. We've got all this data. Hands up if your code isn't under version control. Hands up if you don't use a bug tracker. Hands up if you routinely mine data out of those two sources to tell you how you're doing. Hands up if you've ever fit a curve to that to say, when is the next release going to be ready? Okay. Do you see the problem here? Right? Things are starting to change. Since the mid-90s, there's been a growing emphasis in the research community on actually going out and doing field studies. Instead of saying, I think people should draw pictures, let's put UML in the textbooks and require undergraduates to learn shit that they will never actually use in the real world, we go out and we see what do good programmers actually do? How can we synthesize it and systematize it? So a little bit of humility goes a long way. By last year, pretty much every paper at the International Conference on Software Engineering, the big gathering in our field, that described a new tool of practice, written by somebody under 40, had a field study with it. They went out and they said, we've deployed this, here's what we measured, here's what we found. We can see this change coming. And yeah, a lot of the studies are flawed or incomplete. We're still learning how to do this, but the standards are constantly improving. They're going up and up and up. So, let me give you a classic result. We have known since the mid-1970s that hour for hour, the most effective way to get bugs out of code is to get somebody else to read it. That study has been repeated over and over again. Here's the thing you probably don't know. All of the effectiveness comes from the first reviewer and the first hour. When the folks at SmartBear deployed a web-based software review tool at Cisco in 2002, they could track second by second what people were looking at and what bugs they found. Turns out that if you spend more than an hour on code review, the quality of the bugs you're finding drops off. You got tired. All you're noticing now is superficial stuff. You're not seeing the lurkers that are really going to hurt you. It also turns out that having 3 people review the piece of software is a waste of time. The first reviewer will find most of the bugs. The second and third might find a few more, but it's not cost effective. How many of you rely on Cisco routers? Right? They're kind of reliable, aren't they? You engineer your processes around these findings. One of the rules at Cisco is you can't do a commit of any code that will take more than an hour to read carefully. You build your process around your data. And guess what? You kick ass. A lot of companies will try to sell you software metrics tools. Turns out none of them are any better at predicting either faults or effort than just counting lines of code. Okay. Cyclomatic complexity, coupling factors, blur, blur, blur. Right? If you factor out simple lines of code, that turns out to have all the predicted value. The bigger the code is, the better the chance that you're going to have one bad method, one bad class, or whatever. So all those metrics grow because you've got more code, and therefore more of a chance of having bad code. That's it. We don't know a better measure for code than just counting lines. Do more frequent releases improve software quality? I work at Mozilla these days. We shifted from an 8 to 12-month cycle, as some of you know, down to much more frequent releases. It reduces the number of bugs, but it changes the bugs. Believe it or not, if Firefox is going to crash on you now, it will crash sooner after launch than it did 2 years ago. And we have no idea why. Right? And we're not the only people who have seen this kind of effect. We don't know why shifting to shorter releases has pushed mean time to failure down, but occurrence of failure has gotten shorter. If you have an explanation, I will give you a t-shirt. Quite seriously, we've got tons of data. We have tried lots of crazy hypotheses. We don't know. What about this one? Are there better ways to teach programming than somebody standing up and lecturing? The answer is hell yes. Look at Mark Guzdial's work at Georgia Tech. Look at Beth Simon's work at UCSD. Most profs are never taught how to teach, rather. Hands up if you ever had a bad lecturer. Wait, your hand didn't go up. Outlier. Outlier or dishonest, right? Or prof. So, it turns out that if you teach novices how to program by having them manipulate images right from day one, the very first thing you do is resize an image. You will cut the dropout rate in their classes in half, and the gender balance at graduation, the number of women who go in and stick, will more than triple. And that's a repeatable finding. Gosh, isn't that interesting? Most schools put their fingers in the air and ignore this. Now, I've been talking about quantitative studies. A lot of the really interesting stuff in this field uses qualitative methods. Stuff come from organizational behavior, social psychology. I don't know those fields as well. I'm not a qualitative guy, so when I talk about results, I talk about the quantitative ones. But there's a lot of really interesting stuff coming out of the qualitative side. If you want to find out more about this, there is a book. We got a bunch of people who do research in this area to write one chapter each. What's your favorite result and why is it interesting? There's a couple of chapters in there that are pretty heavy on the stats. You can skip over those to the conclusions. Right? But a lot of this stuff is really interesting. Can you train a machine learning algorithm to look at your code and predict how many failures there are going to be in the next release? The answer is yes. But you need at least 5 years worth of data and a lot of code, and you have to retrain it for every single program, even if it's the same programmers. Little seeds affect the way the code grows. Bad decision 5 years ago might still be with you. So you've got to retrain your algorithms, but the folks at Bell have shown that you can actually predict faults. So, where do you start? How do you do this yourself? Well, you guys are sitting on top of data. I mean, some of you have companies whose whole business is we analyze the data, right? And you're sitting on top of all of this engineering data. If you were manufacturing the cans that Campbell's soup goes in, you would be analyzing your data. You would have been taught how to do that. I've never seen a top-down initiative in this area work. Right? I have never seen the president say, we're going to start doing this, and it turns into practice. Right? What I have seen work is what worked so well in Japan in the 1950s. You identify people who've got good ideas. Somebody puts up their hand and says, I did this and it seems to be working. Somebody else says, gosh, that's interesting, I will try that. Right? You reward them for good ideas that spread. That's the key part. It doesn't have to be a financial bonus, but there has to be something. We adopted your idea because it made our lives better. People are trying it in the trenches and they're rewarded for innovation. You need a way to share those ideas. Well, welcome to DevTL. I would really like to see a DevTL where a bunch of people get up and spend 5 minutes each saying, here's this thing our dev team does. Here's the data we've got to show that it works. Not here's the anecdote. Right? Not, well, it seems to be working, but show us the data. Show us the numbers. Do what you would do for a sales and marketing campaign. Right? And like I said, number 4, how do you tell if it actually worked? We've got data. We know how to do that. Right? And remember, I'm focusing on the quantitative stuff, the qualitative things, the stuff you did in your organizational behavior class if you went through commerce, things like that. There's a bag full of techniques there. I'm not qualified to do case studies or talk about them. It's not my background. Hands up if you ever did a case study in school. Okay, so you know how to tackle some of these problems. Go and try that. Tell us what you find. Okay? Don't know if people at the back can read or not. Terry Pratchett. If you build a man a fire, you'll keep him warm for a night. If you set a man on fire, you will keep him warm for the rest of his life. So, that's where you can find me. I teach programmers, I teach scientists how to program. I work for Mozilla. We're funded by Sloan. Thank you very much.